file, and after so it to your and so in the best I'm going optimization calculate it. The simulation has this and as the azimuth lies so here it is. Assalamu alaikum. Welcome back to our sixth video of PVsyst simulation. So we have done everything in our previous video. Let's run the simulation and check the results. Okay. So first of all, you have to save the file, and after saving it, you have to run the simulation. Okay. So it will take a couple of minutes or a couple of seconds according to your project size or simulation reports. So it will take a bit of things. So if you are feeling something like if you have any question or anything else, you can comment me in my inbox, or you can message me or email me, so you can have you can discuss anything in which you have been like getting errors or not sorting that thing. You can discuss it with me. Okay, I will try to reach out you in as early as possible. So we have 50 seconds ago, 52 seconds, 53 seconds. So basically it is simulation these things and these graphs. So you can see that we are system production is increasing 146 and now 169. So it is increasing gradually as our simulation is performing. So till now we have our project name here and site name here. System type is grid connected simulation. It's means 1st January to 31st December. Generic data which we have provided it. Now PV array, in PV array we have a 580 watt module. Nominal power is 209. Oh sorry, inverter this one. Nominal power we have 209 kilowatt about 2 hour. Number of panels. MPPT voltage MPP, so my mistake, MPP voltage is 43.2. MPP current is 13.5 ampere, and of the PV modules. Inverter unit are 100 kilowatt, and number of inverter we have used are 2. So system production, let's it is going to do 2 to 3 megawatt per year. So let's wait for the yeah, here we go. So let's maximize it. System production is 233 megawatt per year. Specific production will be 1118 kilowatt per kilowatt peak per year. So performance rate will be 0.712, which will be a good sign for my side. Normalized production will be 3.06 kilowatt per kilowatt hour per kilowatt per day. So error losses are 1.13% and system losses 0.11%. So daily input diagram, you can see useful output system energy and global incident in coil. So it is a linear graph, which is a good sign for me. And performance ratio, which is we are doing PR, we can discuss this later on in our report. So in January 0.7%, and February it will be 0. Something 3 or 0.2 or 0.73. So in December and November you can see it is actually it is far better than the June one, which in which actually in June we have very high temperatures in Pakistan, so the performance decreases as the temperatures increases. So system such output power distribution will be like this graph, and area temperature versus effective radiation will be this, which is also a linear type graph, right? So let's save it. We can generate the report, but we have to do some things which will we should have to, like aging factor and other things too. So I will just close it and run the advanced simulation. So in advanced simulation we can name it new simulation. project it's the project details we have selected earlier. Early data storage, you can select the early data storage here from here. I don't need the specific graphs, so you can select the specific graphs from here, but I'm not going to use it there. Batch simulation, if you want to have want to add batches in it, you can also add these things. Result variable like angles, metadata, you can add these things here. So I'm not going to use it. I'm going to use the optimization tool. Okay, so optimization tool actually work like that. Like let's suppose I have some parameters like no parameter, like tilt parameter, and have the azimuth parameter. Okay, so minimum and maximum tilt, let's suppose I have the minimum tilt 15 and maximum tilt I have the 15. Number of steps I will perform is 3, and azimuth, or I will go towards the 90 to 90. Yeah, I'm going to, sorry, let's change this to 20 and 90 to 90. Let's for this, and from this I'm going to use the 3 steps, this one for this, and 2 steps for this one, and this one I'm going to use the parameter. Let's estimated time will be 30 minutes. Let's run this and wait. So basically it will generate a report from for myself to calculate its difference when it is going to be 5 or 20 or minus 10 or 20. So let's wait and see. So here the simulation has been done. The optimization scan is finished, so we will just click the OK, and here we go. So here are the results, which we have the tilt at 5, maximum 20 degree units degree, units is degree, and chapter 2 or 3. Plot 1 or 2D just looks towards the first on the single dimension. Okay, it will the tilt and it will the azimuth. So azimuth will be going to this, and this is like a pyramid shape, and tilt is like a linear degrading system. Maximum at 5 degree is 233.5 megawatt hour, and maximum at 0 degree it's 226.56 megawatt, which is point this one. So if we go towards the azimuth, so if we have the azimuth, these are the azimuths, and these we have the plane like this. So azimuth, and we have the azimuth here and the tilt here. Let's change its tilt and as the azimuth here. So we have a spot lines here which have a linear line like this. So it is around we have a around it is around, I think it is around 5 degree. Yeah, 5 degree, and azimuth will be, so azimuth will be around 0. Yeah, and tilt will be around 5 degree, which is at maximum at 5 degree, and azimuth at 0 degree is 235.5 megawatt hour. So we have the results from here. Variables, we have the A grade, or we have the globation, or we can change the shade, like shade loss is like this. So maximum at 20 degree, and azimuth is 0 degree, so shade loss is 126 kilowatt hour. So we have the global incidence and global effect, and energy of arrays is same like this. So we have the alco, which have the 5 degree, and a payback period. So maximum at 5 degree and maximum payback period is 0. So if we are going to do for the 90 degree minus 90 azimuth, so there will be no other than production like this, so we have no payback period for that thing. So we will go for the let's, the list of skin has changed. Do you want to save the simulation variant? Yes, I will. Yes. So we have the optimizer tool. Then let's go to the aging tool. So it is interesting one. We have the aging parameter, number of years to be simulated. Let's we have a 25 years. Let's long is giving 25 years linear power degradation simulation every 5 years, which will save our times and detail losses. And yeah, these are the things. Great. Let's hide this. I don't need this. If we go for this, no, I'm not going for this. I'm just going for the asset detail loss. This is aging simulation for number. I'm going to increase 25 years. Yeah, that will be fine. That will be fine. That will be fine. Efficiencies and losses are this one. So I'm good with this, and we will run the simulation here. So it is the simulation is running. Let's give it some time, and we will come back to it when it will be done. Okay. So here we go. We have the results. So it have calculated the year 1 to 25. So we have a graph here, and the performance is also here. So let's look it here. At first year it will give 272.4 megawatt hour generation, which will be electrically useful without any losses, including loss after I means after separating losses and other things. Okay, so the production ratio will be 83.09%. So it is will be nice and will be great. So according to this, it will going to the PR will going to 71.21%. So PR loss is going to be minus 14.51, as the longest the degradation will be according to the 0 point something like that thing. So here is the graph. I have similarly the after 5 years, and here also. So show parameters. I have generic parameter 1 to 25. So let's again draw it. So let's useful out. Sorry, effective energy at the output of the array, energy into the grid. So let's effective energy, see the effective energy at the output of the array. So the effective energy that will be generated from the array means panel will be 281.44 megawatt hour. But after losses, line losses, inverter losses, it will be around 272.4 megawatt hour. So that's are the thing which we can inquire. We don't worry about this. So units will be kilowatt hour or megawatt hour, gigawatt hour, whatever you want to set. Let's choose this auto. Okay, we have done with this. Let's click OK. Yeah, I want to save it. Yes, save it. Now just OK and close it. Now we will generate the report. So it is generating the report of the PVsyst, which we have done in this simulation. So it is just ready to go. So here it is. So the how to read the PVC report and other things, and we will change a little of things in this. So we will see this in our next video. So wait, and till then, have a nice day. Good night. Allah Hafiz.